Hi, everybody. So I want to go over slides 8 and 9 for task number 5 in our hunted unit. If you were in the Google Meets, we spent a long time on task number 5, but we spent one full day on getting slides 8 and 9 finished. If you did not get this table filled out for slides 8 and 9, you might want to pause this video and go ahead and do that now so that you can have the correct answers. These first 3 columns right here are all the correct areas for the squares from earlier in this activity. Okay, those are all the correct areas. So if you got an area wrong, now you can go back and figure out what mistake you made, and you can fix it. Remember, to get credit for those, you have to show where those numbers came from. Then for the side lengths of A, B, and C, if you don't know how I got my answers to show up like this is what I did. So when you click into the cell, I believe that was 106. When you click into the cell, you have this little keyboard button. If you click that, it opens up what looks like the calculator. So the side length of A, I would go over here, is 41, or is the area of A is 41. To get the side length, we have to take the square root of the area. So I would do the square root of 41, and then I hit enter on my keyboard, and it automatically will put the decimal version, and it still leaves the number you put in. So it leaves the radical 41 and it leaves the decimal version. So again, if you didn't get this, pause this video and get these inputted in your answers. Now, when we move over to slide 9, it says analyze the data in the table in the previous slide very carefully. Be sure you're looking for relationships between the areas and side lengths of the squares. Can you find a relationship between any of the triangles when looking at their areas and side lengths? Hopefully we can find something that stands out. Is there anything we know about PT that can help us figure out which areas he might be hiding in? Hint, look at what we first learned about PT way back on task 1. Now, to save some time, in class we actually went back and looked at task 1 and read the clues we learned about PT. One of the clues that was the most significant and a lot of students were able to recognize was that he has some notable markings. He has tattoos on both of his wrists, and those tattoos read, "Only if the angle is right." Well, if you come back to this slide 8, you will see over here 2 of our campsites involve the word right, and because they involve right triangles. So based on just that clue, that should help us narrow our information from 6 campsites to search down to just searching these 2. All right, so we're going to focus our thoughts on just these 2. But before I forget, I'm going to go on back over to slide 9, and I'm going to remind myself, hey, we think he might be hiding in sites 1 or 2 because of the sayings, oh my goodness, of his tattoos. Now, don't submit this answer. This answer is not nearly enough information. Now we need to go back to slide 8. On slide 8, we're going to focus just looking at these 2 rows. We're going to ignore the bottom ones. If these are the correct campsites, there's going to be a very significant relationship we're going to notice within each campsite. Now, if you study and look, start looking just at the areas. So if I focus just on these 3 areas right here, what do those 3 numbers have in common? 9, 16, and 25. Well, what was noticed in class was that if I take 9 and I add it to 16, I get the answer 25. Look down here at the next one, 16, 16, and 32. Well, yeah, that same relationship applies. The area of 16 and the area of 16, when you add them together, you get an area of 32, because 16 plus 16 is 32. Very significant pieces of information. Let's go jot those down to add to our evidence of why we think he might be in sites 2. So in site 1, we knew that we saw that 9 plus 16 gave us 25. And we saw in site 2, 16 plus 16 gave us 32. Okay. If this relationship exists for the areas, a very similar relationship should it also exist for the side lengths. Okay. But here's what I know. I know that 3 plus 4 does not equal 5. I also know that 4 plus 4 does not give me a decimal. That doesn't work. However, I have to be able to write a similar equation that works for these because it works for the areas. So I have to somehow make 3 plus 4 equal 5. Super sneaky way to do that. We all agree that we got the 3 because the square root of 9 gave us 3. We got 4 because the square root of 16 gave us 4. And we got 25 because the square root of 25 gave us 5. Well, how did I take 3 and make it equal 9? Yeah, we squared it. 3 squared gave us 9. How did I take 4 to get 16? Sure did. We squared it. How did I take 5 and get 25? Yep. We squared it. Well, 3 squared is 9. There's that. 4 squared is 16. There's that. Guess what? If I put a plus sign in here and I put an equal sign here, I have this relationship. I just made 3 plus 4 equal 5. Well, I really didn't. 3 squared plus 4 squared equals 5 squared. So here's what we're going to do. Come back over to slide 9. We need to put this thinking into play on slide 9. If I come down here and click this type math button, I can actually type what I just had on the screen before. I can hit the 3. Notice, I'll back up a little bit. Before I click that type math button, I have nothing here. If I click the type math button, I get a little dashed box. If that dashed box doesn't show up, you can't do what I'm doing. So I'm going to click the 3. I come up here and click squared. There we go. Plus, how did we get 16? Yep, we did 4 squared. Equals, how did we get 25? We did 5 squared. Very good. And we know the same relationship applies here. So I'm going to do the same thing. How do we get 16? With 4 squared. Yep. Plus 16 again is 4 squared. Equals, this one's a little trickier because I need not 32, but I need what I would multiply by to get 32. So I could use the decimal, or I'm just going to use parentheses. I'm going to say the square root of 32. And then I'm going to click outside my radical sign, do this, and then I can square that. That one's a little trickier. Super sorry, but I think you'll be able to figure it out. Now, we have these two relationships. They validate our reasoning for sites 1 and 2. We liked sites 1 and 2 because they involved the right triangles. So here's what we have to do. We have to prove that it works for any right triangle. So now, instead of using these numbers, what if I plugged in these letters? Instead of a 3, what if I used a letter A? Instead of a 4, what if I used the letter B? Instead of a 5, what if I used the letter C? Here's what that looks like. Again, I'm going to hit the type math so that my little box comes up. A squared, yep, plus B squared equals C squared. You may have heard this formula before. This formula is a super, super important formula that you need for this unit and in high school when you get to geometry especially. And this formula actually has a name. It is called the Pythagorean theorem. All right, this is what we need. This justifies because all of this stuff works, and it works on right angles, and he prefers only if the angle is right. So we are going to say, go search sites 1 and 2. So from here, you would submit this, take a screenshot of slides 8 and 9, go back to Echo, and turn them in.